Hello again, statisticians, coming to you live from my front yard. Hoping the kids will stay busy enough here for a few minutes. A little overview here of random variables, our final probability unit here. Um, First of all, again, just a random variable is um, the idea of some countable value here. If you imagine a situation where you have 10 free throws or 10 dart throws or 10 questions on a test, and the value of x is how many you get right. So this again is going to be a numerical integer value typically that each one has its own probability. And so you can see, for instance, in this grading on a curve idea down here, where we look at the GPA equivalent and the probability of giving out each grade. Just a heads up, the two rules here, naturally these probabilities have to be 0 to 1 inclusive in here by regular probability rules, and they all have to add up to 1. So this what's called a probability distribution here. The collective of that will be every possible outcome. So this is not a situation where we could have up to an infinite number on the top value of x here on the top row. So they'll all add up to 1. And so here, again, this is what, when a student asks if this is going to be graded on a curve, some sort of combination here of grades where C is the most prevalent, and then B and D is next, and then A's and F's are the least prevalent. But again, grading on a curve referring to the normal curve here. And so that's what we're kind of looking at here. So you can see the probabilities all add up to 1. The outcomes, while there is a letter value, we're going to use the GPA equivalent here in our calculations. And the first calculation you look at is how you calculate the mean of something like this. And the mean formula is on your formula sheet. This is the mean for a probability distribution. And what it is here is it's the product of all the individual x's multiplied by their probabilities. Okay, so that's what this is representing here, all the way on until we're done. And so in this particular example here, we'd have the notion that the first x in this case is a 4, or we could have gone 0, 1, 2, 3, 4. Would probably be a little more natural just to have it in numerical order. But our example here would be then that there is I'll start at the 0, so I'll start way down here at the right end. So this would be a 0 times 0.07, which of course would be 0, plus, again, this is summation here, 1 times 0.20 plus 2 times 0.46 plus 3 times 0.20 plus 4 times 0.07. So each of these products, so we've got in this case 0 plus 0.2 plus 0.92 plus 0.6 plus 0.28, and you add all those up, and that would be the mean. So in this case, naturally, because we're grading on a curve, that I just wanted to double check that it was accurate, that this is going to equal 2. So the mu of x would be 2 here. That just means the average grade would be exactly a C here, which is what you'd expect to see when you grade on a curve like that. So that's calculating the mean. Now, as we dig a little deeper into means, I'm going to look at these rules for means, and I'm just going to put together just a kind of a fake example here, a scenario to try and represent this. And on the lesson videos, I used plane tickets. Let's use hotel rooms here. So if I said that the mean hotel room at a certain hotel for a night was $100 even. Okay. Now again, that might be, some hotel rooms are $50, some might be 75, some might be 150, some might be 200. But there'd be a certain probability you get each price at this hotel. And collectively, if we did the calculation like we just did for the grades, the average is $100. Now, B here represents a scale factor. And so a scale factor in this case would be, for instance, how many rooms do we check out on average in an evening? So if we say that for this hotel that they check out, let's say B is 50. So B would be 50 rooms in this case. So scale factor, um, again, scale factors could be if you're selling a product, how many of that product are you selling, or on average, how many of those products do you sell per day, and then the scale factor is the price. Um, so the scale factor is going to be something that represents how many of those means we have, and then let's just pretend here that A is a tax or a resort fee or something, and let's say that that tax is $10. Okay, so what that would represent here now is, and again, if we have 50 rooms, then technically the A at 10 times 50 would actually be $500. So we'll do that for all the rooms. So that would mean for this hotel, the mean of 500 plus 50x. Okay, so again, 500 is that constant, which is the the resort fee or the tax. 50 is the scale factor, which is the number of rooms. And again, x is referring to the values that ultimately led to that mean of 100. So what we would be looking at here is this, what I've just written is this. Now we take that A, 500 plus the scale factor of 50, and then the x, again, the mu of x we're saying is 100, which is what I gave to you in the beginning. So this is a way now that we look at um, how much money, gross revenue, this hotel is getting in an evening, which in this case would be $5,500. Okay, so now that again is manipulating one hotel. So rule one is always about manipulating just a single group. Might be a single product, it might be a single flight, or a single type of ticket on a flight, economy versus first class. Now, rule two is going to be the idea of combining two groups. So in this case, that would be the idea of maybe we have two different hotels. Okay. And so if you own two hotels and one of them is gross revenue on average in a night is 5,500, and let's just say the second hotel has gross revenue a night of $9,000. Oops, sorry, not 90,000, 9,000. Okay, so this would be 9,000. So then if I wanted to figure out the total revenue, that's what this rule two is doing. So it would be mu x plus y would just be mu of x plus mu of y, which in this case would be, let's say this was x, this was y. So that would be 5,500 plus 9,000. So the gross revenue here then would be $14,500. Now the minus here just represents, again, what if we were just to subtract them instead? So mu of x minus y here would be 5,500 minus the 9,000, in which case we'd just be saying that the first hotel in this case has a gross revenue of negative 3,500 compared to the second hotel, or 3,500 less gross revenue. So means in general work very natural, in terms of what happens with these scale factors and the constants, what happens with the actual kind of combining of two groups. Now moving on to the variance side, and this standard deviation variance, and the reason we use variance is the calculations end up being a lot more natural in variance, and it kind of goes back to the idea of squaring and square rooting in our standard deviation calculation to begin with. And so it's so that's what we're going to look at here, and there's more to that, but we'll just leave it at that for now. So when we look at the variance, what we are looking at here in this formula right here is the mu is what we just calculated. So in the grade example, that would be 2. Okay. The x are the individual values on the top part of your table. And then the p is, of course, the probability of that. And what that's going to do is it's going to give kind of a weighted standard deviation or variance, where if something is more likely to happen, then it's going to carry more weight in our overall variance formula. If something's less likely to happen, it will carry less. So for instance here, and you see this is the formula that's on your formula sheet. Again, there's a summation there. That just means you're adding them all up. But if we go back to that grade example, in the grade example, there was a 7% chance that somebody was going to get an F, so that their GPA equivalent would be a 0. So again, that would be a 0 for the X, minus a 2 for the mean, because the average grade was a C, and then the likelihood of that happening. Okay, and then we would add to that the D, which would be 1 minus 2 squared times 0.20, and then we'd add to that the C, which of course isn't going to have any bearing in the calculation, since 2 minus 2, of course, is 0. And then we'd go to the B, which looked like that. And then finally, we'd go to the A. Now, they would never make you do too many of these because it gets to be busy work after a while. But this would be a calculation here that we would probably be expected to make by hand. And then, of course, you can go to your calculator at this point. So in this case, we have 0 minus 2 is negative 2 squared is 4. So we'd have 4 times 0.07 plus 1 times 0.20, and then the next one is 0, and the next one again is 1, 3 minus 2 is 1, 1 squared is 1, times 0.20 is 0.2, so we'd add that 0.2 in, and then again, we'd have 4 minus 2 is 2, 2 squared is 4, 4 times 0.07 would give you another 0.28. So that means that our variance here, okay, our actual variance calculation, in this case, not approximate actually, is equal to 0.96. And again, you can take the square root of that then, and the standard deviation in this calculation is approximately 0.98. That would be the standard deviation. So we take that standard deviation, and again, now we could do things where we manipulate it as we did for the variances as well, or excuse me, for the means as well. So I'm going to actually change again, just to make it a little easier to see the real world element, back to the idea of the hotels. So with the hotel situation, let's say we did this same calculation to get a standard deviation for this hotel up here that had the average room rate of $100 in a given night. So let's say the standard deviation of that room rate was $50. Okay, so in other words, a regular hotel room cost at this hotel was $100, give or take about 50 on average. So we would then take that standard deviation. Okay, so I'm saying the standard deviation here, not the variance, but the standard deviation is about $50. So if they have, again, 50 rooms, then we would say that, and let's say again that there's the $500 that they're going to collect on average from taxes. So you can see here then that the A would be 500 again. Okay, so this A would be 500, the B is 50, and then it's the standard deviation, actually squared of X. And so what happens here, notice the A went away. The A went away because adding 500 just moves you down the number line. Okay, so adding 500 does not make you any more or less spread out. So the A does not affect the spread. The A just affects the mean that they collect, but again, adding a constant or subtracting a constant doesn't change the actual spread of the distribution. Okay, so what we're going to do is take, at this formula, we're going to take the scale factor, which is 50 here. So there's 50 rooms, and square it. And then we're going to take the standard deviation and square it, which we said was 50 over here. So this here, 50 squared times 50 squared, would give us then a variance. Okay, and again, this is variance, right? So it would give us a variance of $6,250,000. Again, that's variance. That's why that seems remarkably big. Okay, so now we take the square root of that, and the actual standard deviation here is about $2,500. Okay, so again, what does this mean? Well, now when we look at this in the big picture, what this means is that this hotel here had a gross revenue of about $5,500, okay, up here on average per night, give or take about 2,500 as a standard deviation. Okay, so those two together would be the center and spread for the gross revenue for this hotel in a given night. Now, the second rule, again down here, is what happens when we would take into account two hotels, okay, like we did up in this section up here. So the two hotels, now we look at this and we say, okay, the first one had the Hotel X, in this case, had a standard deviation of 2,500. And let's just say Hotel Y here had a standard deviation. Again, remember their mean was a little higher at 9,000 up here. So let's just say Hotel Y had a standard deviation of, we'll say, $5,000. So the overall spread then for these hotels would be just what we look at here, would be standard deviation squared for X, that would be 2,500 squared, plus the standard deviation for Y squared, which is 5,000, and this would be our variance. Okay, so we take that 2,500 squared, and we would add to it 5,000 squared, and that gives us this 31,250,000 number. But again, we need to take the square root of that because we want standard deviation, and the square root of that is about $5,590. So what we are saying here then is, oh, don't want that. We are saying, just want to get a little more room under here, that the overall variation in amount of money, gross revenue, that these two hotels make in an evening is about $5,590. So connecting that again up top, that was the mean of 14,500, and that spread is 5,590. So for the two hotels that we said we owned, we're saying on a given night, our gross revenue from rooms is $14,500 with a standard deviation of about $5,590. Okay, so that is Rule 2 in action. Now, the one last note about, two last notes about Rule 2. One is that they need to be independent for this to work. And that has to do with the calculations and the probability distributions and the likelihood of certain events. And the other item here is that when you subtract, in this case, I'll just highlight where I'm talking about here. When you subtract, it still remains a plus here, and that has to do with squaring and the variance. We can't have a negative standard deviation. And unlike mean where we could have a negative, so you always add in this case. And again, you do need to look for that word independent being in the question. So the last thing to note here is just, again, you may end up with some combination of all of these rules together. And again, it's the means are going to be pretty straightforward, and the standard deviations you do need to square and work with the variances. So we'll leave it at that for now. Please let me know if you have any questions. Thanks for listening.